All right, so I'm going to use this equation to show the way that I like to balance chemical reactions. And the way that I like to balance chemical reactions is the very first step is I like to list out all of the elements that are in this reaction. I've got KiO3 plus Ki plus HCl yields I2 plus H2O plus KCl. But my elements are potassium, iodine, oxygen. Well, potassium and iodine are in my next molecule, but then I've got hydrogen and chlorine. Okay, now what I need to do next is I need to define a variable as a coefficient. So A, B, C, D, E, and F. And so now what I have is I have these very simple variables in front of acting as my coefficients, each one of my molecules. So now I can look at each one of the different elements. Potassium, for instance. Potassium, where is it found? Potassium is found in molecule A. And how many potassium are there? There's only one. Okay. Potassium is also found in molecule B. And again, there's only one. Potassium is not found anywhere else in my reactants, but it is found in molecule F. And there's only one of them. So I'm going to write this simple equation that says A plus B equals F. This gives me the number of basically potassiums on the reactant side, A plus B, one of each, is equal to F. Okay. Now, I don't want to do any sort of solving or anything like that because I want to define all of these different equations. But I'm going to write these very simple equations for each one of my atoms. Now, iodine. Iodine is found in molecule A, it's found in molecule B, and it's found in molecule D as a product. How many are there in molecule D? Well, there's two. So I'm going to write 2D. So now I've got two equations, A plus B equals F. If I define all those variables, that's going to give me the number, that's going to give me the coefficients to put to balance all my potassiums. A plus B equals 2D. That would balance my iodines. Now I need to move on to oxygen. I'm going to write 3A. I'm writing 3A because oxygen is found on the reactant side in molecule A, and there are three of them. I'm going to set that 3A equals to E, because oxygen is only found in molecule E. Hydrogen is found in molecule C, and it is found in molecule E, and there are two of them, so I'm going to say C is equal to 2E. Okay. The last atom is chlorine, and there's only one, and it is found in molecule C, and on my product side, it is found in molecule F. Those are the equations that I need to write. Now my goal, my objective, is to get a value, a numerical value for A, B, C, D, E, and F. Now what I'm going to do is I'm going to start out by defining A is equal to 1. Now, I want to define A as 1 rather than as 0 or 2 or anything like that, because that's, well, my simplest number. If I define it as 0, well then you're plugging in 0 right here. And if you have a 0 coefficient, what does that say about the number of that molecule? It tells you have 0 of that molecule. Now 2, well, that could be reduced. So what we want to do is we want to put in 1. And whenever I do that, I survey all of my equations and say, okay, where can I put A in? I could put A in here. I could put A into this one and this one. If I put it into this one right here, these top two, well, it doesn't really help me solve anything. But if I put it into this one right here, well, now all of a sudden, if I say 3 times 1 is equal to E, I know the value for E is 3. Okay, next up, now that I have the value for E, I can plug that in to some other equations. Well, specifically, the equation for hydrogen. That's my dog, Gus. Okay, there we go. C is equal to 2 times 3. As a result of defining that, now all of a sudden C is equal to 6 because 2 times 3 is 6. Okay, now that I have the value for C, well, what else can I get? I can get the value for F, because if I know the value for C, I know the value for F. 6 is equal to F. So now I've got 4 of my 6 values defined. I can look back at those top 2 equations, those ones that were a little bit tricky because they had A plus B equals something we didn't know. Now we have some of that information. And I'm going to start at the top. A plus B is equal to F. I know that I just rewrote that. Now is 1 plus B is equal to 6. If I subtract 1 from each side, now I've got B is equal to 5. A plus B, well, that is now 1 plus 5 is equal to 2D. And as a result of that, 6 is equal to 2D, divide by 2, divide by 2. D is equal to 3. So now I've got this equation. I'm going to erase some of these things. Erase this, 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 this. Okay, and now I'm going to write those values in. I'm going to write them in blue. I'm going to skip over A, because that's 1. I'm going to write in 5 for Ki, 6 for HCl, 3 for I2, and 3 for H2O, and finally 6 for KCl. Now what I want to do is I want to count up the potassium on each side. Okay, so actually I'll do this in a table. REAC, products. He just does that sometimes. So potassium, iodine, oxygen, hydrogen, and chlorine. Potassium, how many potassium do I have on my reactant side? I've got 1 here, 5 here. So I've got 6. How many on my product side? Well, I've got 6 there, so 6. So potassium checks out. Iodine, well, I've got 5 right here and 1 right here. So I've got 6 potassium or 6 iodine on this side. Well, I've got 3 I2, which would give me 6 iodine on that side. Oxygen, 3 right there. And I've got 3 on my product side. Hydrogen. Hydrogen's only found in 1 molecule, that's HCl. I've got 6 on my reactant side, and it's found in 3 H2O molecules, so I've got 6 on my product side. Cl, I've got 6 on my product side and 6 on my reactant side. So I've balanced this equation. Okay, it's a little bit involved. If you like algebra or if you're good with algebra, this isn't too tricky of a process. If you struggle with algebra, I would encourage you to make sure that you practice that. But I think that this is a very effective and efficient way to balance a chemical reaction. I hope this is helpful, and we'll continue on.